All right, so I'm loading up my Jupyter Hub, and then Husky CT is taking its time. Not sure what's going on there, but the main update is trying to turn in project 1 for tomorrow. Does anybody have questions about project or like code or anything? Last time we were talking about like forward and backward difference, like derivatives, and we've only looked at like one integration method so far, just like Euler's integration, which is really like a forward difference derivative approximation to create like integration. Because if you can take a derivative, you can do the integration. Any fun stuff? Something broken, nothing's working, never-ending loop that won't stop. Won't stop, can't stop. I don't know what's going on with Husky CT. I was just going to show the calendar, but oh, there we go. All right. Phew. Dude, I was leaving it off for yeah, looks like some of the grades for homework 1 are back, and Carolyn sent out some nice tips for that kind of work. And then tomorrow we have that project 1, so that's the main upcoming stuff. And then Wednesday we won't have any class, so if there's anything coming up, then you can post like on GitHub discussions, but we'll take a little break on Wednesday and then back on Friday. Sound good? Nice to get like an hour off, just to recover. Nothing? Nobody's like some hard stuff. Nothing yet though. I'll check in, see what people are working on. Yeah, and like we're gonna find better. We're gonna look at like better ways of like guessing check. Yeah. For I didn't know there was like guessing check is like general process is following mind doing a solution that solves more advanced guessing checks. They're all guessing checks. So yes. Yeah. And that's totally fine, especially at this stage where we haven't looked at how to do just things in all new graphs and bracketing and get it lower down and up or down. You think the answer somewhere in there. That's like the other way is if you know, since we know that temperature time manually invert the equation, laws of time is yeah. Pretty close. Yeah. Okay.
So far behind. Can't keep up. Thank you. Like good explain a thing like clearly explain. Don't say I have to redo it. She got 0. I think it is 0. Can't turn right and make a U somewhere. You could if I could faster eventually. It's like, I'm gonna fix this. Yeah. Sorry, I get off of like 2 That's the light. Yeah, the bridge there has been supposed to be done like a year and a half ago. They just finished it. Well, no, it's the smallest. Yeah. But she was like, she was very good. That's a lot of our responses. So you can comment on I can't comment on how you're really from crazy where we live in. Look at these double fingers. I put the like all this like what? I'll look at this too. I'll stay for that. I'll stay. I'll say hi. First of all, I'm like, hello. Thank you for your What's up? Next time we go like for the first time. When it's oh, well, let me go. So I have company. You want to use the Yemi one? Oh, the 85. Oh no, you want to use one of both of them? We said we were friends first time. We're best. Like hard for you. Yeah. You want to see the Roblox? That's us. Like, that's your president's company. You know what I'm saying? When we play, that'd be funny. We could pull up, right? Pull up. Pull up the house? Yeah. Play funny. I have to finish like 17 my project. Oh, yeah. Yeah, I mean, I guess the only thing that I would add would be like something specified, like a downstream system. There's one song called especially if they're bottle. Don't worry about it. Don't worry about it. I'm sure you're always with the well, it's not radio, that's Spanish. You just say shit. That is Spanish. How do you just say shit? I think it's the other way. I just call the motherfucking well, yeah, I have. So what is this? I'm not even Spanish. You remember that? Remember that? I was like, oh my god, that person was so much. It was just the one. I was. I remember that. That's great.
Do you have no questions? Oh yeah.
I just walked around at that point. This is like worse than the last two. So whichever one you choose. I guess you're using both. I'm using a couple of my friends with it. Yeah, so the results are negative. So you're taking negative, negative, and doing it. Yeah. Shows that mention here. But this one, it's just the missing minus sign. Because really, scroll up. We solve this problem saying negative k equals all the way around ta minus derivative over that. Yeah. So no, like ta minus t. What? I have to solve. You have to solve. Yeah, and then you multiply by the negative. So if you're gonna make a minus error, you are so obsolete. Obsolete? I don't know what's this in this context. So now that's positive, and then that should go. Yeah. Yeah. Nice.
So one thing I was gonna say about like whenever you're making functions like in general, the most likely person to like go back and reuse this function is you. Like if you're going back to revise work or you're copying and paste, like let me reuse this to go do something. So give some notes, some helpful hints to yourself of like what are these inputs? Like why am I doing it this way? Like up here, so let me put these on a new line for each one because it's just the way I like to look at stuff. Oh. This is, at least for me, this is kind of my like minimal doc string of like what are the inputs that I want to use for this function. It's like T1 is temperature, like second measured temperature. T0 is initial. And then tell myself like what are the units that I'm expecting, because I'm going to go and use those same units later on. So if I want to use Fahrenheit, then I want to tell myself, hey, I'm using Fahrenheit here. And then same thing for, oh yeah, and TA, more of the same. And then DT is change in time in hours. And then forward Boolean choice for forward versus back diff. I can't spell. Default true. To say like by default it's going to be a forward difference, and if I So if I don't say anything, it's forward difference. If I say false, then it's going to be backward difference. And you don't have to do like all of this. Like if you like kind of testing your own, like pushing yourself to try like if else statements and try things like that, go for it. If you just want to set it up as like, look, take a derivative and give me that k result, and then you can do that. And then, so then the other thing, yeah, let's just look at this. Oh. So let's say like I have either an Euler solution or analytical, but like I have something that if I know the time, I can calculate a temperature. And if you're using a computer, then you don't have to like invert problems yourself. Like you can kind of plug in values and just guess and check your way to an answer. So one thing that I could do to try to figure out like, all right, what is the time of death? When was this function 98.6? Because I could plug in values and just see how close I can get to 98.6. And here, I'll start at like negative 1 point, let's start at like -2 just to see what happens. And then I'll print out T0 and I'm going to print the first time because that's the lowest time, the longest time ago, and the first temperature. And in this case, I get at -2 hours, if I pull this, if I keep plotting backwards, it's 108 degrees. And that's too hot, unless that was the cause of death, like boiling or something. I don't know. Again, this is kind of a little macabre. I don't mean to make light of the subject of death. But, so 2 hours is too long, right? So it's got to be shorter than that. So we could try 1 hour. And at 1 hour, now that's too short. Now it's somewhere between 1 and 2, and it seems closer to 1 than it does to 2. And here I'm using a little bit of my own intuition to solve for this. So it's got to be more than 1. So let's try like 1.3. Now I'm at like 98.15. That's pretty darn close. I can get a little better if I want. Probably like 36. Too big. 34. 98.67. So depending on how good your thermometer is, it's probably close enough. So 1.34 hours ago, something like that. So in terms of like getting that onto a clock, I know it's like an hour and 30 something minutes before 11. So it's got to be like 9, right? Yeah, like 9:20 something. But yeah, we can go through the. All right, so I want. So an hour and 20, is that right? Oh yeah, okay. So an hour and 20 minutes, and then get how many seconds there are. 24 seconds, so that's 11 minus 1. So it's 60. Now I have to do this in my head. All right, so it's 1 hour ago minus 20 minutes. So 9:40, right? 9:40, but minus 20 seconds, so 9:39, and 40 seconds. Is that right? 40 seconds. This is like some pretty high-tech detective work using a Python script. But that's like kind of the guess and check method. And if you're sitting here staring, like, can't the computer do that for me? Like, aren't there ways to do things like that? Like, absolutely. Yeah, we could import from scipy.optimize, import fsolve, I have to make like a lambda function, and I'm gonna grab the thing that I was just plotting. So the main thing is like it's expecting a function with one input. So I'm telling it the one input is time, and then my function is this. So that's what lambda is doing. And then it's expecting like, what is your initial guess? Because it's still, no matter how advanced these like fsolve routines get, they always need some kind of initial guess. So I know it's less than 2 hours, so I could say 2 hours, right? 2 should be close enough. Not making good progress. No. Oh, -2. There we go. Why does it say 87? That doesn't seem right, right? Can't be 87 hours. Oh yeah, I know why. We have to subtract 98.6 because we want to figure out when does that function equal 98.6. So if I say 98.6 minus my function, when that is 0, then I have an answer. Then I get 1.33404, like basically the same answer that I got before, like 1.34, and fsolve in one line gave me 1.334. And the nice part about like an fsolve routine like that is that it doesn't matter how complicated your function is. Like even if you had a huge finite element simulation that you had to run, you could run this and keep checking like how thick does this thing like vary a parameter and keep changing something. When does it reach some desired output? Yeah. And again, this is so guessing and checking like what I just done. It's totally fine. Like we haven't looked at other ways to do that. Or if you want, this is if you can show that Euler integration and this function are the same solution, that you can use either one, and you could also just solve for time as a function of temperature and plug in temperature and solve for that. When is t equal to 98.6? That works too. But yeah, I wanted to bring that up because we were having some little bit of a chat of like, is this it? Is this the way things work in the computer world? Anything else? What else is coming up? Yeah. Just explain how you find the routine again, the negative. Oh, how did I do that? What does that represent? Yeah, so this first line is time, and then capital T is temperature. So that, the function that I just scrolled past, that is like based on our differential equation, that this is the exact solution to that differential equation. So it's an analytical, because for any, if I plug in any time in there, it will give me a temperature value, but it's assuming that it's like everything is staying the same. Like there was always the same amount of like heat generation and heat loss. So as I move backwards in time, if I go above 98.6, then it's not right anymore, because at some point it was just a normal human existing, not a 200 degree. It's not like hours ago it was 200 degree sort of like super person. So this is an analytical equation that we can work forward and backward to, but it's not always exactly what we want. I haven't really done, there haven't been questions about Euler integration. Do you just feel like we got this? Or, yeah.
Can you go backwards in time with the integration?
Yeah, yeah. All right, let's do some of that. Let's do some Euler integration. T future, T past. I'm going to do 2 hours into the future, 2 hours into the past, like a little bit of time travel. Let's do the I'm doing, so Python, you can say like one thing equals another equals another. You do have to be a little bit careful, like especially if it's arrays. Like if you say array 1 equals array 2 equals array 3, and then you start substituting in certain values, then all the values and all the arrays get updated, because it's actually putting them in the same like RAM space. But if you're worried about it, then just make a new line for every time you say like equal to something, rather than setting them all equal to each other. All right, so then we'll say T future of I is going to be T future I minus 1 plus, well, I guess it's minus K times T future bracket I minus 1 minus TA. I'm going to do my fancy click, control, click, control, click. Now you can delete all of them. Type them all in at the same time. So if you hold control and click on things, then you get multiple cursors that you can delete and type all in the same way. Wow. And the only difference between like going into the future versus into the past, oh, and I guess I should have a time step, right? The only difference is that time is either always a positive difference or always a negative difference. So I can change the past to a plus instead of a negative. So by reversing that sign, T comma T future, and we'll do like red, and then PLT plot negative T and T past is going to be, say, like blue, or maybe this should be red, and then this one blue. Oh, K is not defined. Let me define K. Let's just do KB. Now I've got like 4 hours worth of temperatures defined. 2 of the hours went forward from 11 a.m., 2 of them went backwards. And again, like everything above 98.6 is not like a real value, just because we know it would be a very strange heat transfer problem if a person was 110 degrees. Not that it can't happen, just that it's very odd. So what I might want to do is like correct all the past temperatures. Like if it's above 98.6, just set it equal to 98.6. So I'm using like some logic in what's called like Boolean indexing. So I can find all the, whenever this statement is true, it's going to index all of the T past events when that statement's true. And I can set them all equal to 98.6. So now when I look at the plot, it looks a little more like what I would expect. So at some point there was just a 98.6 and then something happened. Then we had just general convective heat transfer problem. That also gives me another point of like, how do I find that point in time? I can look at all the 98.6s until they start dropping and find like the last time that it was 98.6. So if I just look at the temperature, like T past, when is it equal to 98.6, it'll give me this. And then if I say, since time is the same thing, did I use T? Yeah, because I'm not very creative. Then it'll show me, if I replace it, now it will show me all the times when temperature was 98.6. So the first one was 1.18 hours ago, and the last one was 2 hours ago. And here it's different because I use a backwards integration. Oh my god. I want to double check that it gives us the same answer. Yeah, 1.346, which is, we've been getting 1.34. So as this catches up with us, we get 1.34 hours ago, which is exactly what FSALT gave us, and guess and check gave us that. So it's all coming together. Up on the board. It depends. Oh wait, you are using forward and backward.
Oh, we're saying you were
KB.
check out.
Only if you're trying to like get exactly what I got on the board, then I was using K.
Oh,
Average.
why am I seeing
But
Because I was trying to, so this is the internal.
yeah, so if you're trying to use that,
And then I just
that's
managed
the
to like
process.
find the.
But you can use forward, backward, or average. They're all.
This was the last time I talked to Alex. That one. How about you say that wasn't good? Going to that.
So the oil integration is basically just modeling. So I just use the model of that.
That was the last one.
So I modeled it like that. Like future and past.
So what like the like that one guy?
No.
Okay.
I knew you were gonna say that.
So what is this?
This is just from like future and past ones.
What do you mean like you should this is the UL integration to me.
It's not you.
This is the UL integration.
But it's not. So you can basically just have like a regular organization here and then this is divided and then plot the analytical and show us I just use one. This was just
Yeah.
so he like separated it into like two separate modules. So basically one was like future temperatures, but
Yeah, they're all ending.
Yeah, how's it going? Why start zero?
it doesn't start.
Right time that's in the like 13. We also have the final future
Do you mean like the graph you just made?
Yeah.
I mean, yeah, it is. But I think he was calling so that you can see, like, split it up into like what does each time look like after and what times. It was more just like pinpoint like how many like attitudes.
Yeah, but that is the oil in the method, right?
Yeah, I think it is. I have to.
Because it's like a function, it's like a formula, it's got the DP in there.
Yeah, I think.
That looks like
No, the same thing. I just like these are different solutions for. I just use like the last part of that model.
So, what part of the course, like the work we just saw, that this might be I think it is.
Yeah.
I mean, kind of. Because we did the time step.
We should
I do
definitely do
DT.
this.
0.2 on the DT and then I will change the step size or something like
Do the
that.
same thing
Yeah.
with the equation and cost of
Step time.
Well, I mean, we have the DT and another section. Do this.
Rate one DT is 0.04. So
But
very
this is
small.
this is way by definition, by definition. But this is literally, we will.
Okay, well then do that, it's just.
So this is for part A, you choose the part of A. So, and then the pass is for part C. Because he's trying to figure out how to do. Yeah. Yeah. You're on that?
Yes,
I'm confused, but they're confused then.
I'm not confused.
I was confused. This one is it.
I'm just saying he's doing that to answer my question, which I was like, is there another method?
Yeah. There's multiple ways. This is one of the ways we can do it.
Yes. So, what I did is,
Yeah. I wasn't saying they can't take it. Consider sources. That's the main way to say. Pursue legal action against me. It's the formula right there. One step. Yes. So wait.
So they should be getting closer. This is just like case. I'm actually still looking forward to it.
Oh. That's how you're have to educate you guys. Apollo future?
Yes.
Well, that's not even the point right now.
So yeah. This is your number.
Yeah.
Who's that?
Project should.
Yeah.
Okay.
Right, no, we do the one. Go. What's your?
Oh, my bad. Sorry.
Also mentioned you
Dude, what is this?
define the functions, but then I pull out so then what I'm gonna do? Yeah, okay.